everybody. Welcome to Buffalo Brief. I'm Kelsey Anderson.
And I'm Dave Graber.
All right, today we have a traffic story. So,
A couple of weeks ago.
Yes, we had the Amherst town supervisor on, and he talked about some congestion in Amherst. We know there is a lot of buildup in Amherst.
Yep.
There's a lot of development happening there, and we specifically asked him about some intersections we've noticed have been a little congested, and he said, well, we're actually using AI technology in some traffic lights to help with that congestion and otherwise. And that sparked something in me that, that would be an interesting guest on Buffalo Brief to talk to, the people behind that technology.
Absolutely. And because you sort of, there's that kind of historical thing when you come up to a light and you're kind of looking for like the weight, and is that really what it does these days? And it used to be like that. And I don't know. And sometimes I know that there's one light at the end of my street, and I've been talking to Amherst about this constantly, but it is such a long
You're that
light.
annoying resident.
I'm such the annoying resident. I'm begging for this technology that we're going to spend the next 20 to 25 minutes learning about, because it's almost like the light is timed, and regardless of whether it's 2 o'clock in the morning or noon on a bright sunny day, that light is the same exact timing every single time. And I'm sitting there at the end of and there's no traffic or anything like that. I can't say that I've always obeyed that light, but
Dave.
You're right. But it was very early in the morning when I was working wake up at like 3 o'clock in the morning.
Dave and
There was no one around.
Are you rule breaker, rule follower over here?
That's true.
All right, let's get these guys in. Myovision is joining us now. They came all the way from Kitchener, Ontario to join us to tell us about this technology they have all across Western New York, not just in the Amherst area. We have Joel Quigley from Myovision, an engineer, and Carl Putty, the Northeast U.S. Sales Director. Thank you, gentlemen, for joining us.
Thanks for having us.
Yeah, thanks very much.
So let's talk about what exactly the devices that we're talking about. We actually had a couple of photographers out. Shane went out yesterday and shot some video of the devices. So we want to make sure that people know exactly what we're talking about. And it's one of those things that before, I feel like even maybe Sean talked about it here on the podcast, or we were talking about it. It's one of those things that you don't even notice. You pull up to an intersection, you go to a stoplight, it turns red or green, and you react accordingly. But if you take a glance up, I feel like there's a lot of hardware up there on those things. So what are we talking about, guys?
Yeah, typically, so our installation is comprised of a single point 360-degree camera. It's actually mounted above the intersection, either on the vertical strain pole or on the mast arm that holds the signal lights. So this camera is situated above the intersection to get a total bird's eye view of the intersection. And what this camera does is it basically identifies all the objects moving about the intersection from this single point of view. So traditionally, sensors were built in the ground. Those would be referred to as like inductive loop sensors. We've basically taken this sensor out of the ground and put it in a bird's eye view so that you can see all of these different types of road users moving about the intersection.
Interesting. So if you're watching us, you can see it looks like a little candy cane,
so neat.
A white candy cane. There it is. On top of, people are now going to look up and notice this technology there. What exactly is the camera gathering? Is this something that police are working with you guys for, or this is just for congestion and other things? You're not really taking pictures of people's license plates. What are you doing exactly?
Exactly. So there's no license plate reading technology built into the system. There's no facial recognition. This is strictly for sensing traffic. And what we can do with that is identify 6 different classifications. So we can identify light vehicles, buses, articulated trucks, single unit trucks, bicyclists, and pedestrians. So we can basically educate the signal lights themselves and the traffic controller in the cabinet with our device what object is where. And that can basically control or actuate the signal based on demand.
So the way that it used to be, was it a weight, or was it that like detected a vehicle, or what? How did it used to? Was it weight?
Yes.
Oh,
yeah,
wow.
it was a weight-based sensor. Now, obviously, that has limitations.
Sure.
Obviously, in terms of the size of that sensor to capture the different types of vehicles. And a pedestrian or a bicyclist is not going to set that type of sensor off.
So interesting. So when you guys do this, is it sort of the camera and the AI recognizes what's there, and if there's not traffic, let's say coming one way, will it instantly, or is it like pressing the crosswalk button, like it starts to cycle the light.
Yeah, exactly. It's called actuation. So it'd basically be informing the traffic controller that there is a car waiting for it, in which case it would then trigger to cycle to serve that. It does not happen instantly for safety reasons.
Sure.
There is traffic rules that need to be followed, but certainly it would kind of address your situation that you've described
Right?
earlier. It would see you, say, hey, he's waiting. Let's go service him. Yeah.
These are the guys to actually talk
I
to
know.
about this
Listen,
situation, by the way.
When that conversation started with Sean, my mind just, the gears started
When
rolling.
you say Sean, we're talking about
Sean
Sean
Lavin,
Lavin,
yeah,
the
sorry.
supervisor in Amherst. All right, let's talk about how this technology has improved over the years. Maybe Joel, you're a good guy to answer this as the engineer. When you started, what did you see? And now today, what can you see in these cameras and what they are capable of?
Yeah, for sure. So I think when we're talking about traffic technology, as Carl mentioned earlier, the kind of the original were inductive loops in the pavement of the road. A lot of limitations with that, a lot of issues, especially up in here with snow plows going over it, weather.
Right.
So it was a lot of maintaining issues. Over the years, it kind of did progress to video-based technology, but it started with a per approach camera. And what that means is that you would have to install 4 cameras per approach to see every approach and be able to detect the vehicles. Where we came in is we have a single point camera, as Carl mentioned, which is able to see the entire intersection with 1 camera. So the benefit of that is 1 camera for an install, you're off the road, so it prevents a lot of the the salt spray or the truck spray, keeps the lens cleaner, and it's just a much simpler install. Where we have taken it a step further now is layering a data set on top of that. So rather than just identifying a vehicle and letting the traffic controller know about it, we are now taking it a step further of identifying the different classes, the exact movements they've made, the commonly referred to as turning movement counts, which then traffic engineers can take that data and now try to optimize the traffic performance.
So it's not even just the live video and the actuating of the system, but it does while we're talking about facial recognition, it doesn't do that. It doesn't read license plates, but it does track data like aggregate data, basically.
Yes.
Boy, that's got to be a huge benefit for these traffic departments.
Huge benefit. Before, what they would traditionally do is they would set up temporary cameras.
The little rubber things,
or
right?
the road tubes,
Yeah.
exactly. And that would be a 3 or 4 day spot study. We've changed it where we're doing it 24/7, 365 now. So it's a much richer data set. And the next step we're taking too is safety analysis. So we're actually monitoring that intersection and identifying any potential conflict that occurred, commonly referred to as a near miss, where an accident did not occur, but it almost occurred. So we can plot that and inform the traffic engineers about those issues, where then you could identify problems before they occur and hopefully prevent an accident from happening.
That's amazing.
That is.
How often are, traffic departments in these towns around here changing traffic signals, changing the infrastructure based off of what your camera is gathering?
Yeah, do you want to?
Yeah, certainly. We do see retiming efforts undertaken by the various agencies that own the signals. I do know for a fact the Maple Avenue and the Worley Avenue corridors, those were undertaken on a joint effort, which is really nice to see from our standpoint. We have multiple stakeholders all working together to retime and improve the flow of traffic. So this is something that the agencies are constantly looking at, evaluating, and working on. To kind of bring back the AI component, the system that we have is actually continually learning and using a graphics processing unit at the edge of the roadside to basically understand and evolve, its classification capability from understanding pedestrian to bike to light vehicle to articulated truck and bus. So it is a system that is using AI to continually improve that across all different weather conditions to give that kind of best underlying data set back to the end users.
So what I'm hearing you say is that when you first started these programs, it could identify, as you said, pedestrians, bicyclists, cars, trucks, semis, that kind of thing. But what the AI is doing since it started, whatever these programs are, it is learning to better identify and I guess the weather plays a role, especially in Western New York. Difficult to identify maybe a person that's all bundled up versus like a motorcycle or a bicyclist or something like that.
For sure.
That is where this is improving in those finer details.
Yeah, exactly. So
Gotcha.
it's basically using it's teaching itself.
Got it.
So it's able to kind of use that historical situations and learn from it and get better from it. So it's continuously learning, and then from there we can also layer on additional features or data sets, kind of the conflicts, safety conflicts that I referenced earlier.
That is so neat.
This should have been a question I asked immediately when we started this, but how many intersections have this
Right.
technology here in Western New York? What towns, are really using this technology, Carl?
For sure. So the town of Amherst has all of their owned traffic signals utilizing MyoVision's technology. Town of Tonawanda also has all of their signals. North Tonawanda has a good amount of their signals. I'm not sure if it's completely 100%, but it's very close. City of Buffalo is adopting probably around 60 signals, and then New York State Department of Transportation Region 5, which is kind of the global state-owned intersections in this area, they probably have close to 150 plus, potentially nearing 200. So overall, and then you add in Village of Kenmore, there's Lockport, a number of other agencies that have cameras here and there as well. So at least there's 440 cameras today deployed. And then at a kind of looking throughout the rest of this year, there's probably annually, I'd say 40 to 50 cameras that go out in this region.
I was on the phone with Carl a couple weeks ago to set this up, and I was driving by Sheridan in Delaware, and I looked up, I said, oh, there's one.
They are.
And then I was driving down Sheridan, and I'm like, oh, there's another one. So they really are all over the place.
Are they, so when you say Amherst, they have them on 100%. I know that that it's not on the end of my, the light at the end of my street, right?
We're going back to this.
We're going to figure this out. No, I'm just kidding. It's really not that big a deal. I'm
We
being
can get you
facetious.
one.
I'm being
We'll do that.
facetious.
It's
I'm totally being
personal camera.
facetious, yeah. But so does that mean that they don't necessarily have to be on every single light or every single intersection, but they are on that network, in other words? So if you're at an intersection, you don't see it, it doesn't necessarily mean that there's not that system working at the intersection. It's just a camera's not needed there because of the lack of traffic.
Yeah, for sure. I think there's, a variety of different ways of detecting vehicles. We're one option, so there might be a different technology there doing it. Or to your point, the city or the agency may just determine that this intersection does not warrant that technology due to volumes.
That makes perfect sense.
I want to mention that Dave lives on a cul-de-sac of one house, and he's talking about, no, I'm kidding.
So when you have those sort of voids in the system, doesn't really make a difference because at least the towns that are participating thus far, they're really hitting their most heavily traveled areas. So we're talking about the intersections that get the greatest amount of traffic anyway, right?
Yeah, exactly. And a city or a traffic engineer generally knows, their problematic intersections, and that's generally where they'll start with first, and then they'll kind of build from there. So certainly, heavily trafficked areas are somewhere where we really thrive, and then also kind of like downtown cores and kind of put that on a corridor.
This is kind of moving into helping pedestrian safety as well. So now when we stand at an intersection, we want to cross a busy street, you push that button, it can kind of flash at you. It can, tell you with a little whistle or, something that, don't walk or walk. That could be changing in the future, potentially, if the towns kind of buy into this technology. And if a pedestrian walks up, your cameras can automatically switch lights for them, right, Carl?
Yeah, certainly. We would call that pedestrian detection or pedestrian actuation. So the camera has that capability. If the controller at the signal has been programmed to take a virtual or a video detection input to actuate the signal, we could then provide that actuation if someone does not push the button. By no means are we saying, remove the buttons, go away with the buttons. That is still a very excellent ground truth. Just in a lot of cases, you look at COVID, people weren't, wanting to touch things so much. So there is that additional capability of sensing from the video camera side as well. And then sometimes, maintenance is a common occurrence. Sometimes the buttons may have stuck stuck buttons, or the wire could be pinched somewhere, so it's not actually placing a call. So it's just an ancillary component to be able to run that intersection in a safe manner.
It's really cool. So you said Buffalo is now embarking on an order of 60 of these. Have you guys started that process yet? And then I guess my other question is 60 enough for a city like the size of Buffalo? Or are they saying, hey, we like you guys. We've seen you have a good track record. Let's start with this initial order, and then we'll see if we go more?
Yeah, I think from that standpoint, there are a couple other avenues that the city is looking at as well. When you're looking at technology from improving the infrastructure, there's detection is one component, but we also do provide communications from our device. So without the camera, we can still provide communications to understand, is that light cycling? What's the status of that signal today? So there are avenues like that being explored as well, as opposed to not, having to jump right to the detection standpoint. So as Western New York is, growing and adopting new technology, they're also looking at kind of scaling that foundation of that pyramid. So they may not be starting out with cameras everywhere right now, but we certainly are providing other components as well.
Nice.
You guys are in town today. You drove a couple of hours to be here, but you didn't drive here for just us. You're meeting with some town leaders and state leaders today to talk about some new technology. Do you mind sharing what some of that new technology is?
Of course, yeah. It's a really exciting one for us, and I'll let Joel jump into it a bit more. But the gist of it is, now that there's all of these sensors and all of this data being collected, we want to create an engine to basically improve that data analysis. And I'll let Joel go on this one.
Yeah, I think we kind of refer to it as a decision-making assistant. So if you can imagine a city that has 100, 200 of our systems, that's an overwhelming amount of data for an individual. What we're coming out with is an assistant essentially on our platform where you could ask it questions and communicate with it. So, hey, what are my top 5 most trafficked intersections? Wow. And it would then generate that for you. So it's just a way of kind of aggregating that data and bubbling up the important stuff where you can then communicate with it, ask it questions. So we kind of refer to it as a traffic engineering assistant within our platform, which we are kind of releasing very shortly here.
And that's AI technology.
It's all AI technology. So it's an AI solution.
Conversational
AI. Yeah, exactly. So it's very interactive, and you as a user on our platform can kind of use that to ask questions, aggregate data, and get answers very, very quickly.
Wow. So you guys are, and maybe we should have started with this one too, are among the only games in town, among the only companies that provide these kinds of services. And in fact, what you were saying, Carl, before we started was these guys are actually second to the market here in Western New York, but now have sort of taken over. Can you explain that process? Because ultimately, I think the question that we'd like to at some point finish with is, what is the future of traffic? Obviously, the future is, or the priority is moving from point A to point B as efficiently and safely as possible. But I'd like to know what the future of that is. So when it comes to that specific detail, how does that work?
Yeah, for sure. So the AI engine that we're providing behind the data set, that is, we're the only company in the world that is currently doing that.
Very cool.
I do know we have patents pending for that technology. From that kind of foundational layer, they're thinking 20 years down the road, there's the whole aspect of connected vehicles and being able to communicate traffic light information to these vehicles. Take that a step further and look at, are these vehicles going to become autonomous?
Autonomous, right.
So can the lights, and all of that underlying information be provided to those in the, OEM standpoint? So we do also have a V2X strategy that we're currently providing signal information directly to vehicles today. We feel that, OEMs are really interested in that potentially for this kind of autonomous world that may be, many years down the road. But
it's kind of like we need the infrastructure in order for that sort of next step, the autonomous vehicles.
Yeah.
You guys are kind of providing some of that early infrastructure, right?
Absolutely, yeah. Wow. We're kind of building that foundation that this entire solution network would rely upon.
There is, it is fascinating.
That's fascinating.
There's even one more layer. We talked about the vehicles and the pedestrians, but first responders, you guys also help them with your technology as well. Will you go into that technology and how you can potentially turn red lights into green, that sort of thing?
Yeah, absolutely. I can kind of explain that. So that's called emergency vehicle preemption. And that is where we do actually instantly turn the light green for emergency responders. So the way we would do that is we connect to the vehicle, the emergency vehicle, in a variety of different options. We don't have to get into the details of that, but then we know the location of it and the status of it. As they are driving to respond, we know where they are, and then through our solution here, we can actually make that intersection turn green for the approach they're coming, they're approaching the intersection at, and get them through, on the green. And we can do that for their entire route to their destination. So that's called emergency vehicle preemption. That is instantaneous. We are turning those lights green for them to ensure that it's as safe as possible.
So do they put, where they're going into some sort of GPS system, or just as they're driving, your cameras are signaling and recognizing?
So we're actually not leveraging the cameras in that situation. We would be leveraging the GPS information from the vehicle itself. So we are able to connect to that vehicle, get that information, and know real time where they're going through the network, and then turn the light green based on their location.
And is that happening here in Western New York, in any towns?
Yeah, absolutely. So the emergency vehicle preemption is pretty widespread. We're actually, there's another option, which is a transit signal priority, which is not necessarily we turn the light green 100%. We suggest to turn the light green to get the bus going further. So we're actually doing a project on Niagara Street right now, kind of testing that technology out.
Oh,
Ooh,
and you mentioned a bus?
Yeah, can you explain that a little bit more?
Yeah,
on
for
Niagara
sure.
Street, how it would apply?
Absolutely. So with NFTA, they have on Niagara Street, we're working with them. We're using our technology. We know the location of the bus, and then we can suggest to the controller to give it an extension on a green to get through that intersection. Ideally, what we're trying to do there is ensure that bus maintains an on-time schedule.
Wow.
All right, so that's public
That's super
transportation we're
interesting.
talking about, not
Yeah.
first responders anymore.
Yeah.
Very interesting. And we know here in Buffalo, this is not a knock on the NFTA. We have late buses
Yes.
continuously in the wintertime
People complain
because it is so messy out there. And it's harder for those buses to get around.
Yeah, and that's where this technology becomes a bit more conditional, right? Only provide that suggestion or only provide that grant to that, green if the bus is behind schedule.
Got it.
You don't want an early bus by any means, but this can even be applied individual vehicle sensors, things like snowplows. If you're moving a large amount of snow, and let's say that blade is down, and you can know that blade's down, maybe then provide the preemption to move that vehicle with that heavy load of snow. Let's say that blade's up, and you have that information, then it's just spreading salt potentially. So you might not need to grant things like that. So the system can be very conditional on what it's wired up to. For example, if a ladder truck, a fire truck is in the middle of the intersection and that parking brake's on, let's stop calling preemption for the next intersection. So you can kind of have things.
How do you know the truck's parking brake is on?
So we
that
are
technology, apparently.
Wait, how do you know that?
Yeah, so we're leveraging we're leveraging technology that already exists on that emergency vehicle.
Got it. So they send signals out.
They have their own information. We're just tapping into that
Got it.
to provide a service for them.
That was fascinating.
This
I
is
thought,
all
how do they know?
amazing.
So
Yeah.
I guess people should feel really good about, because no one likes traffic, right? It's a pain. But it's been that way since the beginning of automobiles, and even before that, just people walking around, right? So traffic is always a thing. But people should feel pretty good about the fact that not only does this technology exist and that it's being deployed quite widespread across Western New York in some of our most populous towns like Amherst, for example, but also that you guys are participating and that our local leaders are getting together on a monthly basis to talk about traffic improvements. People should feel good about that.
Yeah, and honestly, from covering, I've been at MyoVision 7 years. I've covered the Northeast U.S. To be honest, I have not seen the cohesion and the working group like exists in Western New York.
Wow.
That kind of,
Love to hear that.
Yeah.
you know, the mix with NITEC and the local MPO and all of those individual municipalities that own their own signals, that is a working group that, you know, works together. And I honestly have not seen that replicated in such a cohesive manner. That is really fantastic to see. And it's great because it's the whole spirit of having all of these systems, all of this data together, and being able to, you know, help these agencies move faster by applying an AI agent for them to, you know, potentially understand quicker, you know, what to do and how to troubleshoot.
Yeah, I would just add too that traffic is in that unfortunate situation where people only notice it when it's bad.
Right.
Yeah.
When it's good, no one thinks about it. But yeah, to Carl's point, and people are trying to improve traffic for everybody.
Great.
And I will say, I don't know that we have the issues. I know we don't have the issues that
It's 20
other,
minutes
that other
regardless,
cities have.
Even in traffic.
But yes, I and that could be because of what you guys are doing as well. So I do notice
Right.
that it's not that big of a deal most days.
Could it help in places like Atlanta, like Washington, D.C., where you're talking about most of that traffic is highway based, right?
Yeah, absolutely. So although we don't have solutions that directly get installed on the highway, when you think about the interchanges or, you know, the off ramps, certainly that's where we can
Got it.
deploy our
That makes sense.
technology.
Yeah. Very cool.
Yeah,
that's really neat.
if traffic's all diverted off at one spot, that traffic's going to have to go through a handful of signals.
Right.
So that's where
Get 'em off.
Yep.
That's right.
That's very cool.
All right, very good. Guys,
Huh.
anything else that
It's
we did
fascinating.
not ask about?
Don't think so.
No, I think you did a
covered.
great job. Yeah.
Okay, great.
excellent.
Wonderful. Thank you both for joining us, Joel, Carl. We really appreciate it. And maybe down the road, we can do another update on this.
Yeah.
This technology is ever evolving.
Absolutely. Thank you for having us.
Yeah, thanks, Kelsey. Thanks, Dave. Really appreciate it.
Yeah,
It's a great conversation. The future is here, folks.
Yeah, and
It's
I love
here.
that it's here in
I know,
Western
and it's
New
here
York.
in this room. Yeah.
Okay, we will see you tomorrow for Buffalo Brief. Thanks for joining us.